Well, hi everyone. My name is Federico. I'm the founder of Evmos, and today I'm excited to talk to you guys about our EVM extensions and the path to first-class precompiled contracts. This is gonna go through the journey of why we need precompiles, how they're different from smart contracts, and also explain how we're using them on Evmos to use native functionality from from the Cosmos ecosystem, like IVC, which is the interoperability protocol. A little bit about me. I've been in Cosmos ecosystem since 2017 when I started my career. First as a full stack engineer, and then part of the core team that built the Cosmos SDK, Gaia, which is the Cosmos Hub, and later the IVC protocol. Since 2020, I've been working on Ethermint, later known as Evmos, which is the EVM implementation on Cosmos. And today I'm going to explain how we're using that technology together with our EVM extensions. So the first definition that we're going to explore today is the difference between smart contract and precompiled contracts, or precompiles. So when we have usually Solidity contract, there's a definition whether or not it has a compiled bytecode, which is the one that is deployed to Ethereum. For that, we need a Solidity compiler or an EVM compiler that goes from a smart contract to bytecode, and with an AVI that defines basically the interfaces to interact with for a Web3 dApp to interact with that smart contract. So the compiler allows us to transform that Solidity file into the bytecode, and then that gets deployed into the Ethereum network by submitting an Ethereum transaction that calls traditionally the create opcode. And then that returns a contract address, and then with that same AVI, which can be used by explorers, etc., to verify smart contracts, you can interact with that decentralized application by just like AVI encoding the call data and then interacting with that contract on the Ethereum network to execute any smart contract behavior. But then the Ethereum yellow paper clearly specifies an exception to the execution framework from the EVM, which is these 9 different addresses, these 9 different programs that are called precompiled smart contracts that execute native logic. In this case, for example, if you're using Go Ethereum in Go, or if you're using WETH, you can use, it's built using Rust. So these precompiled smart contract, basically what they define is these exceptions that have, as the name said, precompiled, so that you can interact with them. You have a predefined input that is defined with a corresponding output structure, and also the gas requirements. So this is how traditionally an EVM stack call works. That usually you have the transaction that goes through all the pre-checks. You transfer the value, and then the EVM calls the call opcode. Or in this case, if you're talking about like Go Ethereum, it calls the call function. But then it checks whether or not the code associated with this particular address that you're calling has length that is more than 0, and for that, it checks if this if it's not, then it calls a associated precompiled contract if it's already registered in the EVM. So by this, you run the smart contract. It has a required gas function that allows you to see what's deterministic gas that you're doing for this operation, and then it returns the value, which then can be used by either EOAs or smart contracts. So these are the list of available precompiled contracts that exist right now on Ethereum, and by definition, they're mostly used for gas-intensive or computationally expensive gas operations on Ethereum. So for example, we have the Ether recover to to verify the public key signature using the hash of the provided message, and then you have the VRS that outlines the signature. And then you have other cryptographic functions like the ones that we define here for point addition, etc. And there's even more that are only on testnet and not even defined on mainnet, which for example are the Blake functions. So there's a lot of discussions right now on Ethereum Magicians forum whether or not some implementations might require a precompiled contract versus like a native contract. And there's it's a chicken and egg problem whether or not it should be defined as a precompiled contract. The benefit of including a precompiled contract is that you can deterministically define or like arbitrarily define your gas requirements. So as opposed to deploying your own smart contract, which might be very gas efficient, you can just define a cheaper gas requirement on the native code for that same operation. And one big push that has been going on Twitter or X right now is the addition of the EIP 7212 for this new elliptic curve that might enable functionality like passkey that together with account abstraction could define better ways of onboarding new users, because this curve in particular is the one that secure enclaves on iOS and Android devices use for passkey technology. And it can also introduce new signature verification for IoT devices, so microtransactions between IoT, and it has like a wide variety of uses. So there's really a push for including more. There's even suggestions on the Ethereum forum about abstracting the way that precompiles can be defined, and in the Ethereum white paper even says that eventually the idea was that these precompiled contracts can become native extensions to the EVM so that you can deploy additional functionality without having to go through core changes. And for example, abstracting the create2 functionality to create deterministic precompiles is something that has been recently discussed in the forum of the Ethereum Magicians. So yeah, as I mentioned before, like one big push that today you've probably seen if you're using iOS, Android devices, 1Password, and virtually any new authentication device is the push for these passkeys that are being integrated into different services that create a binding between the secure enclave of your device and the application itself. So it's a better and more secure authentication framework than the one that, for example, WebAuth uses, or even 2FA with password currently creates. And it's also backwards compatible. So this could be potentially a way for onboard new users, and the precompiled contract that specifies this elliptic curve, the 7212, is going in this direction as well. But little is like commonly discussed about the vulnerabilities of precompiles, and for this I'm going to refer specifically to a category of the precompiled contract that is called stateful precompile. There are 0 stateful precompiles right now on the Ethereum EVM, but certainly there are more stateful precompiles on other layer 2s and other EVM implementations. And the main difference is that these stateful precompiles, as the name says, can execute state transitions. So for example, executing native calls on like Avalanche or Moonbeam, etc. And the common vulnerability here is the misuse of delegate call, static call, and call code, which are passing in the context from the caller to to the precompiled contract, which might execute common vulnerabilities. So this vulnerability has been present in Aurora, Hedera. Moonbeam also had a similar vulnerability. So this is, if you're building stateful precompiled contracts, this is like the critical thing to look for when you're developing these type of solutions that are using the state. So now let's dive into the EVM extensions, how Evmos is using the stateful precompiled contract implementation to interact with native code. So for the ones that are not familiar with Cosmos, Cosmos allows different core functionality like staking, IVC, which is the inter-blockchain communication protocol that today makes Cosmos famous, governance, and it also can provide additional functionality that is defined by the application-specific blockchains. In this case, Evmos also provides additional functionality, for example, for vesting accounts, etc. So how it works is that you pack these calls in a nicely way for using an AVI call. So we made changes to the EVM, to the AVI, precompiled contracts, and we also introduced a feature toggle for this. So how it looks into the EVM is that we modified the run function, and we also added a few additional nice to have. For example, like if the precompiled contract is stateful, and we also added the contract ref, which provides the address. So this allows you to run the contract and actually know whether or not if the call that you're executing is a stateful precompile or not, without that is handled in the implementation of the precompiled contract. So the next step is also defining the AVI, which is a different solution than what Ethereum precompiles right now use, which it just provides an input of raw bytes. But we can actually abstract that functionality and provide an AVI for which you can define methods and function signatures to call specific functions within the precompiled contract. So how it looks like is you define the event, you define the function, and then that specific method is handled within the implementation. And so for the precompiled contract itself, then by providing the method, you can abstract the arguments that you provide, so like the remaining of the call data that is not the signature, and then unpack that into a meaningful data using the AVI, and then call the corresponding core functionality. And this has been proven really useful for us and for the entire implementation of these IVC integration. So how this looks like from our perspective is very similar to the execution environment that we discussed before, but here we are checking if the precompile is stateful, it calls the Cosmos module or the Cosmos functionality and then returns. It's pretty much the same, but the functionality is handled with an AVI interface on top. And we also introduced a feature toggle. So as I mentioned before, we have this chicken and egg problem between adding or not adding functionality to the EVM. It might be breaking, changing. So we added a feature toggle so that we can, for example, enable some of these functionality on testnet but not on mainnet, so that developers can start trying it and interacting with their dApps on testnet. And as long as it gets sufficient support, the precompile will go to mainnet. So our outpost, how it looks from a product point of view, is that we can abstract a lot of this functionality from by interacting with other Cosmos chains. So outposts are specific applications that are using the AVI interfaces from other chains. So for example, liquid staking, which traditionally takes multiple calls here. Stride is one specific solution. So this implementation reduces the amount of transactions that a user need to make from 4, potentially 3 if you don't have the gas function, to just 1 transaction that executes using the AVI, calls a Stride outpost, which is a precompiled contract, executes the ICS transaction, and then returns the value once it's handled on the Stride. And this is how it looks like from a product point of view. It's like an instant dApp, as we call them, and you can submit a 1 liquid staking transaction with full composability with other Cosmos chains, just from the EVM. And then one big push that we're making is issuing native tokens as ERC20s. So one big problem that the whole ecosystem has is that TIA, Celestia tokens, and other tokens in the ecosystem are not ERC20 compliant, so that means that they're not supported by wallets, EVM wallets, and other clients in the space. So how do we make that? Is by defining an ERC20 API interface and handling that data as if they were an ERC20 token together with a precompiled contract. And one big push that we're doing right now is adding interchain accounts so you can manage with an EVM account your account and other Cosmos chains. So for example, I'm not sure if a lot of you, given that there's a lot of contributors to the Ethereum ecosystem, claim their Celestia airdrop, and for a lot of people was the first experience downloading Cosmos Wallet. So for this, you can now interact natively with your normal EVM wallet, execute a cross-chain transaction, and manage your portfolio assets from other chains just using one single transaction on the EVM. This is all done through our EVM extensions and precompiles. And finally, we recently announced our plan to deprecate Cosmos transaction by nicely packing this functionality using our EVM extensions and outposts, so to create further alignment with the Ethereum community and the Ethereum ecosystem. Thank you very much, and I also invite you to join our builders Telegram chat in case you have any questions. Thank you very much.